So you're going to have 4 questions. And they're going to be the same okay, and they're going to be the same. Oh, my eyes are very bad. So you're going to have the first question. You're going to have the first question. This is not going to the question 1 is going to be like the second test. It's going to be first law, closed system. Okay, and the first law closed system can only be, what we have learned, it can only be 2. What are the kind of system? Can anyone help me out? Say it out, please. What is this I'm drawing? Can you all say it out?
Rigid tank.
Yes, it can be a rigid tank, and if that is so, volume is
Constant.
Constant. Or it can be
Piston cylinder device.
Yes, piston cylinder device. And here, volume
May change.
may change. For instance, if you heat it up, what's going to happen?
Workout.
You're giving energy to it. What's going to happen?
The piston will move upward.
Yes. And what do you call that?
Workout.
Yes.
Expansion.
Yeah. See, it's expansion. So if you heat it up, if you supply, I'm going to call it energy lah, don't say heat. Say you supply energy, in this case, it's heat, And so what is going to happen is this piston, the volume may change because the piston is going to move up. The piston is going to move up, and this is what we call as work boundary, because the boundary is moving. So in this case, this is going out of the boundary. So this is work boundary out. Correct. Yeah. Similarly, if you have a piston cylinder device and there is work compression, so here we have expansion because V increases, right? V increases, volume expand. Now, if this is compression, then volume decreases. That's it. And you might even lose heat. Okay? So, now, if you have boundary work, can you evaluate the boundary work? How do you evaluate boundary work? Can anyone tell me? What's the equation for boundary work? Anyone?
PdV, integration of P dV.
Yes, integral P dV. Yeah, and this needs to be written for each process. You may have 2 processes. First, this thing goes up or this thing goes down. And then suddenly you have a stopper here. Yeah. When it's going down, it's constant pressure. Once it's stuck here, then it's constant volume. So you have two processes. So you have to write the boundary work for each process. So work 1, 2, for instance. Integral 1 to P dV. Work 2, 3, integral from 2 to 3 P dV. This may be a constant pressure process. This may be a polytropic process. It depends. And the equations, do you all know the equations for each type of processes? What if it's a constant volume? What is the equation? What's the equation if it's a constant volume?
0.
Hello? What's the equation for a constant volume? Hello? Anyone?
Doctor, it's 0.
What? Who told you?
It's 0 for constant volume.
Okay, for constant volume it's 0.
0.
What if it is a constant pressure?
P times delta V.
Constant volume, right? What if
Yes.
it's constant pressure?
P times delta V.
Delta V. What is delta V?
V2 minus V1.
Okay, what if it is a polytropic process?
PV power of N.
Yes, so what is the equation?
Is constant.
Polytropic.
PV ln
P what?
V2 divided by
Oh,
V1.
yeah.
P1 V1
V4, final minus?
initial.
P ln
Okay,
over
over?
1 minus N.
There you go.
Yeah.
So this is how you evaluate boundary work. Now, once you do that, you have sometimes you need to find, for instance, they say find the heat. Yeah. So if that is the case, then you will need to, what do you need to do?
First law.
You have to write the energy balance. So first you did the boundary work. Integral P dV for each process. And then you need to write the energy balance for each process. So how do you write the energy balance? Q in, what else?
Minus Q out.
Minus Q out.
Plus W in minus W out.
Plus W in minus W out equals to?
Goes to delta U.
Okay. So, hang on. Sorry, I'm having a class. Sorry, I'm having a class. Okay. So now it depends on the unit. Yeah, it depends on the unit. So be careful with units. Be careful with units. All right. So if the problem does not ask you for instance, for instance, if they want you to evaluate certain things in, for example, find the Q, yeah, for, you look at the unit, yeah. So this Q dot is kilojoules per second. If this is the case, you will need M dot. M dot is of course in kilogram per second. But if the questions wants the Q in kilojoules per kilogram, here you do not need, sorry, mess. You need mass. Mass is in kilogram. Now, so if they ask you in kilojoules per kilogram, you do not need mass. So don't panic. Madam, no mass. Where's the mass? My question got no mass. You don't need the mass. If the question says per kilogram. Is that clear, everybody? Is that clear? Yeah?
Yes, doctor.
Yes, doctor.
So you must ensure what is the unit that's asked. Okay, but important thing is you need to do this for each process. That means you look at the problem, and see, is there any Q, is there any W, is it coming in, is it coming out? Yeah, and then you simplify that. So that means for, say, for process 1 to 2, yeah, there is heat loss. Say there is heat loss, right? So therefore there is no Q in, there is only Q out. So you're going to put here minus Q out, yeah, and this thing is, say there is some work in, so plus work in, there is no work out, equals to delta U. Okay, so this delta U is of course U2 minus U1. And if this is a general system, then you need to use tables. When I say tables, mean if it is water or refrigerant. Okay, then you will need to use tables. Then you do the same thing. Process 2 to 3. Maybe by this time there is no more heat. Yeah, so maybe there is only work in. Okay, and how do you evaluate this work in? This is where you go back to the boundary work. If it's work in, here you will get negative value. You will get a negative value because the V has reduces. Yeah, so you get a negative value, right? But when you put it in here, yeah, when you put it in here, this is work in, so you get negative 5. What you put in here is 5 because this is adding the work in. You're adding the work in. Okay, so if it's a compression, you will get negative work. If it's expansion, you will get positive work. Okay, you will get positive work in that. All right, okay. That's what you need to do, yeah. So what I would like you to remember is that, yeah, importantly for this question is that you must define the system. You must define the system. If it's water or R134A, use the tables and state postulate. That means you need 2 properties. If you are not given, the second property will come from the process. And then if you need to, you will need to do interpolation. Now I'm going to ask you, does everybody know how to do interpolation? Hello? Does anybody know how to do interpolation?
Yes, doctor.
Okay, I can guarantee you, I can almost guarantee you there will be interpolation. Okay, so you will need to know how to interpolate. So make sure you know. If you don't know how to interpolate by now, you better learn. You can ask me if you want to. Okay, I will be up all night waiting for you if you have any question. Okay, so it is important that you know how to interpolate, and as well as you must be able to draw TV diagrams and PV diagrams. So TV, show the process. That means you must state, oh, this is state 1, this is state 2, this is state 3, or you have another one. Okay, say you have another one. Okay, this is state, for example, 3. So show this on a TV diagram or a PV diagram. The difference between a TV and a PV is the PV comes from the top, and this is temperature. This is lines of constant pressure. Okay, so that is what I need you to be able to do. Okay, so you must understand how to find boundary work from the integral PDV. You understand expansion is positive, compression is negative, work in, work out. Unit, be careful if mass is not given. If the answer once is per kilogram, then the mass will not be given. Okay, so are there any question on this? Are there any question on the closed system? First law of closed system. Are there any question on the first law of closed system?
No, doctor. Thank you.
So the second question will be on first law, open system. And we are only going to look at steady flow, right? And how many devices? Can you all tell me? I'm going to write down here. How many devices have you learned? How many devices? Can you all? You can put in the chat room if you like. You can put in the chat room. How many devices? Well, name me, sorry, not how many, sorry. Name me the devices, please. What are the devices? What are the devices? Yes, you have heat exchanger. This was in test 2. Okay. Oh, what is that? Okay. So you have heat exchanger. What else do you have? Turbine. And turbine will involve work out. Okay. Forget about condenser. Condenser or heat exchanger. Okay. So you already been tested heat exchanger in test 2. I'm quite sure that it will not come out again. Okay. So yes, you have compressor. So you have work in. Yes. Somebody was talking about there. I saw a nozzle. Okay. So here nozzle, no work. Somebody said valve. Yeah, usually throttling valve lah. Throttling valve, one that you can open and close. Of course, here also no work. Right. So this, yeah, these are the because you know, these are the open system that we are familiar with, we have studied. So you must be able to understand the function. What is the function of a turbine? What is it used for? Yeah, it's an expansion device. This is an expansion device. This is a compression device. Yeah, this is what? What happened in a nozzle? Is it expansion or compression? What happened? Okay, so valve, here usually we want velocity increase. Yeah, so we want the increase in velocity. Here, throttling valve is usually is an expansion device as well. Yeah, it's just like the turbine, only thing, and of course, the valve does not have any work, right? Right, so these are the open system devices. So I need you to read about them, yeah, and of course, to understand the function, what does it do? So you can go to the textbook, yeah, you can go to the textbook and have a read, quick read, okay. Then you will need to analyze them, okay. So in analyzing them, first, what you need to do is you need to write what's the equation you need to write? Mass flow rate equation, which is m dot area times
velocity
divided
by specific volume.
Okay, that's all you need to do, right? So if it is a general system like steam, or a refrigerant, you can go to the steam table to get the specific volume. Okay, use table if you have water or R134A. We use equation if it's ideal gas. Yeah, so PV equals to RT. So P1 V1 RT1, P2 V2 RT2. Yeah, and then you find the V. Area is of course pi d squared over 4 if it's a circular cross-sectional area. So that's the first equation. What's the second equation? What's the second equation?
Mass balance.
Mass balance. Okay. Just look at the mass. How many in? If there is only one in coming in and one is going out, yeah. There you go. And what is the next equation? And forget about this long equation. If read the problem. Does it say neglect changes in kinetic energy? Neglect changes in. If it says that, yeah, alhamdulillah. Okay, so you don't have to worry about that. You only have to worry about m dot in, h in. Yeah, if it's compressor, you have W work in. If it's compressor, right? So W work in equals m dot out, h out. Is there any q out? If there is, then you have to put in lah. It depends lah. Okay, so simple, right? Okay, so if you have W dot in equals to m dot, if it's the same, here is m dot, then you have h2 minus h1, say this is 2, this is 1, plus q dot out, right? Now, if this, see delta H here, okay? So this delta H, if it is stable, you can go to the tables for water or R134A. If it's an ideal gas, this will be Cp delta T, Cp T2 minus T1. So it depends. So the question can ask you for mass flow rate. If it's mass flow rate, you can use this equation here. You can use the mass balance. You can use the energy balance to find the m dot. If they ask you for enthalpy, then you will have to use the energy balance equation. If they ask you for work, in or out, you have to use the energy balance equation. If they ask you for temperature, If they ask you for pressure, then you will have to use this equation. Because here, for instance, you can get temperature from there, right? So it depends on whatever the question wants. But very, very simply, you just need this. You need this. You need this. And of course, all the PV equals to RT or the tables. Are we clear on that? Everybody? Any
Yes,
question?
doctor.
Any question? Any question?
No, doctor, thank you.
Okay. So remember all the examples that we have done in class. Okay. Now, of course, the third question will be on the second law. You have to start with the Carnot principle. What does the Carnot principle say? What's the Carnot principle say? Anybody? What does the Carnot principle say? Anybody? In the chat room? You will need to write, Amirul, you will need to write the general equation. Yes, you will need. All you need to write there, because there will be marks for it. There will be marks for it. There will be marks for the equation. Okay.
But if they say to neglect the KE and PE, do we need to write KE and PE also?
Then you don't need to write.
Oh, okay.
Just like what I did. No need to write the KEPE. Okay. But usually, even if you neglect the KE and PE, they might give you velocity because they want you to calculate the mass flow rate or the specific volume or the area or the diameter. So they will give you velocity, but in the energy equation, no need to put if it's neglected. Okay? But they will give you because sometimes you need to calculate, for instance, area or diameter or specific volume. Okay? Okay, any more questions? Good question, Amirul. All right, so on the second law, what is the Carnot principle? Hey, everybody, tomorrow is the test and you don't know what Carnot principle is? What's the Carnot principle? Everybody? What? Okay, before I do this, I think there are some questions. I'm going to clear this. Yes. Yes, Iftikhar, they will tell you whether to neglect or not. Okay, they will tell you, right? So you must remember what's important is depending on the system, yeah? This is still on the second law, yeah? I'm still talking about the second law here. Okay, I'm still talking about the second law here. So if ideal gas, please use the ideal gas equation. Yeah, please use the ideal gas equation. So either P1, V1, RT1, P2, V2, RT2. Okay, because you might need the specific volume, for instance, if you want to calculate the mass flow rate. Area times velocity divided by specific volume. So the specific volume, yeah, here. Of course, it depends. If talking about area 1, then this is A1, V1, V1. Yeah. If the mass flow rate is the same, then this is also equals to A2, V2, V2. If it's the same. Okay. But if you use this 2, 2, 2, 1, 1, 1, just like you just P1, V1, RT1, P2, V2, RT2, right? So again, if it's ideal gas, yeah, temperature must be in, I will strangle anyone who uses Celsius here. I will strangle you. Beware, it must be in Kelvin. Okay, be in Kelvin. Okay. Then whatever is in kilogram per hour or kilogram per minute, convert to kilogram per second. Okay. And another important thing is for ideal gas, delta H is equals to Cp delta T. Delta H equals to M Cp delta T. Are we clear on this? It is ideal gas. Okay. Right. Now, you're going to the second law. Carnot. What does Carnot say? What does Carnot say? This one I want you to remember forever and ever, okay? The efficiency of the Carnot cycle or the reversible is always higher than the irreversible. That's what Carnot says. Yeah, that's what Carnot says. Always, always. Reversible cycle will always have a higher efficiency than the other thing it says is if it is a Carnot reversible, it will have the same efficiency with another cycle 2 or reversible 2 if they are operating between the same two temperature reservoir, TH and TL. Okay, so when you write the equation, if it's an irreversible heat engine or cycle, then you will have the efficiency of the, we call it thermal, or irreversible, or irreversible, will equals to QH minus QL over QH, or work out over QH. But if you have a Carnot or reversible, then that is equals to QH minus QL. Of course, this is maximum work. Yeah, so this will also be TH minus TL over TH equals to work maximum over QH. So this is the equation that you can use for reversible. So all this has to do with the Carnot principle. Okay. Any question? So in the second test, you had the heat pump and the refrigerator. So I believe, I'm sure, final exam will cover all. So you need to know about the heat engine. This is the heat engine, yeah, as well. But of course, what you need to do is you need to be able to draw the schematic. There will be marks for the schematic. So if you have a heat engine, remember, heat engine is from high, yeah, heat engine is from high to low. I have a terrible handwriting. Okay. Heat engine is from high to low. So it goes from T high, supplies Q high to a heat engine, and it goes to TL. This is QL, and you have work out. Now, if you have a heat pump or a refrigerator, yeah, then the reverse is going to happen. Okay, so you're going to have the heat pump or refrigerator. So the refrigerator or heat pump, it will take heat from the low temperature and it will transfer heat to a high temperature. And it requires work in. So you must be able to draw this schematic. If you still don't know, go home and practice. Okay? Now, once you've done that, you know the efficiency of a heat engine will be QH minus QL over QH, or work out over QH. If it is a reversible or Carnot, then this will equals to TH minus TL over TH, which is work out max over TH. Okay, this is for irreversible or actual. Similarly, with the heat pump or the refrigerator, depending, COP heat pump will be what you want, QH over QH minus QL. COP refrigerator will be QL over QH minus QL. Okay, and if it is a reversible, yeah, if it's a reversible, then for example, QH over QH minus QL for the COP heat pump would equals to TH over TH minus TL. COP refrigerator reversible or Carnot. Reversible or Carnot, then it will be TL over TH minus TL. So the important thing is read the question, read the question, read the question. Is it talking about a heat engine, or is it talking about a heat pump, or is it talking about a refrigerator? Because the mathematics is so simple. I cannot imagine you getting wrong. Read, is it talking about reversible, or is it talking about an actual or irreversible? Read the question. Does it mention Carnot? Does it mention reversible? Does it mention maximum or minimum? So read the question. You all did very well in the second test. I assume that it's going to be similar to the second test, but you need to read. Read and read. Do not misunderstand the information because the mathematics is too simple. Schematic must be drawn. You get marks for that. Write down the efficiency equation. Write down the COP equation. Write down the energy balance, which is work net equals QH minus QL. So these are the equations that you need to write. Depending whether you have a reversible or irreversible. Okay, clear? Any question on this? This one should be direct, straightforward, just like the second test. But you must find out, this one, is it heat engine? Is it heat pump? Or is it refrigerator? Read, 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 read. Okay, any question on this? Any questions? Are you all asleep? Good morning, good afternoon. Are you all asleep? Asleep, are you? Okay, so any question on this? Second test was okay, right? I see a lot of full marks. Yeah, so I expect to get full marks again on the final exam, right? So last but not least, entropy, okay? So as I said, entropy will cover everything. So you must know how to find the change in entropy. Okay, so if you don't use, if I say cover everything, so if you don't use the equations for entropy, there must be something wrong with your answer. Okay, you must, just like just like the second law, you have to write down the energy balance equation for the cycle, the efficiency equation. If you don't write it down, there's something wrong. If I don't see the equation in your answer script, there's something wrong. Okay, so delta S in entropy, there will be change in entropy for sure, right? You must know how to find delta S. How do you find delta S? You can go to the tables or you can use equation. So please, equation is for what? If you have an ideal guess, then you will need to use the equation, right? What is the delta S for ideal guess? Everybody, please. What's the equation for ideal guess? You have to memorize it by now. Yes, Imran, CP. Can also use CV, up to you. Which one you want to use? Yeah. I'm not the one taking the exam tomorrow. So this unit will be in kilojoules per kilogram Kelvin. Unless you multiply it by mass flow rate, then you will get in kilowatts per Kelvin. Okay? If you multiply, this is small s, delta S, you multiply by m dot, for instance, CV ln T2 over T1 plus R ln V2 over V1, then your units will be in kilowatt per Kelvin. Is that clear? Everybody? Or you can also use the other equation for delta S. What is the other equation? Can someone help me? CP what? Ln what? Can I hear?
Ln
Yes, Amiro.
T2 by T1
T2 divided by T1 minus
minus R ln P2 by P1.
Right. And again, if you multiply by the m dot, then your units will be in kilowatt per Kelvin. Otherwise, it's kilojoules per kilogram Kelvin here. Okay. So this, if you don't use this equation, if it's an ideal guess, and if you don't use this equation, there's something wrong with you. If it's the table, if it's water and R134A, and you don't use the tables to go and find S2, this could be superheated vapor, compressed liquid, saturated vapor, SG, SF, whatever, right? So there's something wrong with you. Okay, everybody can find delta S. Is that a yes or a no? Everyone, yes or no?
Yes, doctor.
Yeah, you should be able to find delta S either from the table. This is like before lah. If it's superheated, go to the superheated table. But of course, you must ensure you know what is the system. If it's water or R134A, go to the table. If it's ideal gas, here. If this is ideal gas. If it's R134A or water, use that. Are we clear? Okay, if you use this equation, what is the temperature should be in what? Temperature must be in what? Everybody, can I see in the chat room? Temperature must be in? Yes. Kelvin. T in Kelvin, or I will kill you, right? Oh no, I won't kill you. It's Friday, I will not kill you. Temperature, I will kill you on Saturday. All right, temperature will be in Kelvin. Temperature in Kelvin. Temperature in Kelvin. How many times have I to repeat? 3 times, okay. Temperature in Kelvin, temperature in Kelvin, temperature in Kelvin. Okay, I don't know how else to talk to you. Pressure in what? Pressure in what? Kilopascal, kilopascal, kilopascal. Okay, so that is the delta S. And of course, you will have to find S gen. Yeah. And S gen, depending whether you have a closed system or an open system. Okay. And S gen, you can find either delta S system plus delta S surrounding. You can find it that way, or you can use the S gen for control volume, M dot, if you only have one coming in and one coming out, MISI minus Q dot over T. Of course, this is in kilowatt Kelvin. This is the exercise that we did earlier. Again, here, if there is only one in and one out, SE, this is S in, yeah. And again, this is delta S. So either you use the table or you use the CP, CV, ln T2 minus Ty minus ln P2 over P1, P2 over P1, or CV ln T2 over T1 plus R ln V2 over V1. Okay, so that's how you evaluate that. Yeah. Okay, and then what does okay, if you want to find this Q, okay, right, you must make sure this is surrounding will be Q surrounding over T surrounding, right? So this is T surrounding. And this T must be in what unit, everybody? Kelvin, Kelvin, Kelvin. Now, this Q here, this is system. If you use this equation, this Q is system. So that means if the system is losing heat, then it will be minus 20 or minus 60 or whatever. Okay? If the system is losing heat. If the system is gaining heat, okay, what is it? If the system is gaining heat, hello, are you with me? Everybody, did I lose someone? Did I lose someone? Okay, what is this? All right. Okay, so, can you see my screen? Can you still see my screen? Yeah.
Yes, doctor.
So if you are losing heat, this Q system will be minus 50 or whatever. But if you are gaining heat, then it's minus plus 50 or plus 10 whatsoever. So look at the example that I've given you earlier. Okay, so, and then of course, you will of course remember to use the increase in entropy principle. What is the increase in entropy principle? What is the increase in entropy principle? What is it? It has to do with the S gen. If S gen is equals to 0, what do you have?
Reversible.
Is it possible?
Yes, possible. Actually.
Yes, possible. Okay. What if Sgen is greater than 0? That means it's a positive value. What is this?
Irreversible and possible.
Reversible, it is still
Possible.
yes, possible. If it's less than 0,
Then it is impossible.
impossible. Yeah, why? Because you have violated the law.
Second law of thermodynamics.
Cannot be negative, must be positive.